Hi, this is Mrs. Rodriguez, and this video is for Algebra, Algebra 1B, and this is a lesson for 7-6, all about growth and decay, okay? So I'm just going to go through a couple of examples for you. Let me share my screen with you. So like I said, this is Algebra 1, lesson 7-6, growth and decay. All right, so you need to be familiar with the exponential, the equation for exponential growth. So it's y equals a times the sum of 1 plus r raised to the power of t, where y is the final amount, a is the initial amount, and then r is the rate, and then t is the time, and make sure that is in years, okay? Okay, and then one thing you want to make sure is when you write the rate, it is a decimal, not a percent, okay? All right, so let's look at an example. It says a college tuition has risen 5% each year since 2000. If the tuition in 2000 was $10,850, write an equation for the amount of the tuition T years after 2000, and then predict the cost of tuition for this college in 2015. So again, remember our exponential equation is y equals a times the sum of 1 plus the rate times the time. Okay, so now we're going to fill in some of this information with what we're given. So we know we're looking for y. The initial amount was $10,850, and then 1 plus the rate, which was 5%, which we have to change to a decimal. So we would express that as 5/100, and then t is time. We could rewrite that as 10,850. We can add 1 and 5/100. So that'd be 1 and 5/100 to the power of t. So that is our equation, okay? So now it asks you predict the cost of tuition for this college in 2015. Okay, so we're going from 2015 and it started in the year 2000. So that's a difference of 15 years. So now we're going to substitute that into this equation. So we've got y equals 10,850, and then 1 and 5/100 to the power of t, which we are using 15 years. Okay, so then when we multiply, or not multiply, first, remember you got to use order of operations. You got to take 1 and 5/100 and raise it to the 15th power. Make sure you're using a calculator for that, okay? It's about 2 and 789 10,000ths. And you can just save that number in your calculator and then multiply it by 10,850, and you end up getting $22,556 and rounding off about 37 cents, okay? And you would round it to the hundreds because we're talking about money here, okay? And that should be your final answer for that one. All right, so then there's a specific equation here for a particular type of exponential growth, and it's compound interest. Okay, so here's the equation. A, which is the current amount, is equal to P, the principal amount, times the sum of 1 plus the rate divided by N, which is the number of times the interest is compounded each year. So if it's like quarterly, that would be a 4. If it's weekly, that would be 52. Monthly, that would be 12. Okay, and then all of that raised to the power of n times t. Okay, so let's look at one of these examples. So it says determine the amount of an investment if $300 is invested at a interest rate of 3.5%, compounded monthly for 22 years. Okay, so let's remind ourselves the equation is A, the amount, times the principal, 1 plus the rate over the number of times the interest is compounded to the power of n times t. Okay, so we're looking for the amount. the principal amount is $300. Okay, and then we've got 1 plus the rate, which was 3.5%. Even though there's a decimal there, it's still a percent. So we have to change it to a decimal. So that's 0.035. And then raised to the power of n. Now it says it's compounded monthly, so that n would be 12, and then the time is 22 years, okay? So we've got A equals 300, and then 1 plus, oh, this is 35 thousandths over n, which was 12 over here, okay? So we've got 1 plus, when you take 35 thousandths and divide it by 12, you get about 29 10,000ths. And then 12 times 22 is 264. So then we would add what's in our parentheses first. And when you do that, you end up getting a repeating decimal here. And then we're still going to raise that to the power of 264. So obviously you're going to be using a calculator. These are really large exponents. I don't expect you to spend your whole life multiplying that out. Okay. And then when you do multiply that, you get 2 and 1,573 10,000ths. And just so you know, I tried this on my phone calculator and it said error, but if you just Google like free scientific calculator and you type that in, it should come up with an answer, no problem, okay? So this is, when you multiply this, just keep it in your calculator, don't clear it, and then you multiply by 300, and then it ends up being $647.20, okay? So after 22 years, that's how much money this person will have in the bank after it's compounded all those times, okay? All right, so the last set of problems is about exponential decay. So again, there's an equation for exponential decay. The only difference is instead of adding the rate, you are now subtracting the rate. So one big clue here, your final answer should be smaller than the initial amount because whatever it is that they're talking about, it's getting smaller. It's a decay, okay? All right, so let's go ahead and look at this problem. It says the population of Campbell County, Kentucky has been decreasing at an average rate of 0.3% or 0.3% each year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. And then if the trend continues, predict the population in 2010. Okay, so again, our initial amount was 88,647. So our final amount should be less than this, okay? If not, we did something wrong, okay? So again, our equation is y equals, this is the final amount is equal to the initial amount times the difference between 1 minus the rate time raised to the power of t, the time, okay? So we're given the initial population, which was 88,647, 1 minus the rate. The rate, remember, is 0.3%. Okay, even though there's a decimal, it's still a percent. You have to change it. So it actually ends up being 0.003. So we have 0.003 to the power of t, okay? So we could even simplify this equation by subtracting 3 thousandths from 1. We end up getting 997 thousandths to the power of t. So that's our equation. And then it's asking to predict the population in 2010, okay? So from 2010 to the original year, which was 2000, it's a difference of 10 years. So now we're going to use this same equation that we just figured out, and the t, or the time, is going to be 10 years, okay? So when we do that in a calculator, of course, 997 thousandths to the power of 10 ends up being 9,704 10,000ths. This is when you round it off. Keep it in the calculator, and then you multiply it by 88,647, and you end up getting 86,023. And there's a decimal, but obviously you can't have part of a person, so it ends up being about 86,023 people after 10 years. So we look at our original amount was 88,647. So our new population is less, which is what we wanted, because remember, this was exponential decay. Okay? All right, and that sums up lesson 7-6, all about exponential growth and decay. So hopefully this video was helpful. Thank you for watching, and hopefully I'll see you soon. Have a good day.